Hi everyone, we will see more examples on Moore machine. Construct a Moore machine if the input ends in 101, output is A. If ends in 110, output is B, otherwise C. That means there are three cases. If the string ends in 101, output is capital A, and if the string ends in 110, output is B, and otherwise C. Start constructing the Moore machine. Starting with the Q0, if the string ending with 110, the output should be B. So the minimum string is Q0 on 1, it is reaching the state Q1, and Q1 on 1, it is reaching the state Q2, and Q2 on 0, it is reaching the state Q3, and output is B. That is on 110, it is reaching the state Q3 and output is B. Now we will start designing. String ends in 101, output should be A. So 1 already seen on Q0, and Q1 on 0, it is moved to the state Q4, and Q4 on 1, it is reaching the state Q5, and output is A. Because with 101, it is reaching the state Q5 and output is A. If the input is only 1, it reaches the state Q1, it falls into the third case, so output is C. If the input is 1, 1, it reaches the state Q2 and it falls into the third case, so the output is C. If the input is 1, 0, it reaches the state Q4 and it falls into the third case, so the output is C. If the input is 0, the output must be C. If the input is 2 zeros, output is C. If input is any number of zeros, the output is C. So Q0 on 0, it is moved to the self state and output is C. So let's start designing the other input symbols in all states. Q2 on 1 is not defined. If it is standing in Q2, that means already 1, 1 is seen, and Q2 on 1 means one more 1 is seen. It is ending with 111, so output should be C. And if it has seen any number of ones, it should be C only. Q2 on 1, it is in the same state Q2 and output is C. So now we will design Q3 on 1. If it is standing in Q3 means already 1, 1, 0 is seen. If on that, if 1 is seen, it is ending with 101, so that the output should be A. So that it has to be connected to Q5 with 1. Q3 on 0, that means already 110 is seen. If one more 0 is seen, the output should be C and it has to go back to the starting state. So Q3 on 0, it is moved to the state Q0 and with the input symbol 0. Now we will design Q4 on 0. Q4 means already 10 is seen. If one more 0 is seen, the output should be C and it has to go back to the starting state. So Q4 on 0, it has to go back to the state Q0 and the output is C. Now we will design Q5 on 0. Q5 means already 101 is seen, and on that if 0 is seen, that means it is ending with 10. If it is ending with 0 means it has to reach the state Q4. So Q5 on 0, it is moved to the state Q4 and output is C. And Q5 on 1 means Q5 means already 101 is seen. On that if 1 is seen, that means it is ending with 11, so that it has to reach the state Q2 and output is C. Q5 on 1, it is moved to the state Q2 and output is C. Now on every state, every alphabet is defined with the outputs. We will see the next example. Construct a Moore machine to print the residue modulo phi of input treated as ternary. Ternary means the number system base is 3 so that it is using the alphabet 0, 1, 2. Residue modulo phi means when it is dividing with phi, the remainders are 0, 1, 2, 3, 4 we are going to get. These will represent the input numbers and equivalent ternary. That means when it is base 3, so that 1 is represented with 1 and 2 is represented with 2 and 3 is represented as 1 0 in base 3 and 4 is represented as 1 1 in base 3. Similarly, we have represented up to 14 in ternary, that is base 3. When 1 is divided with 5, the residue is 1. When 2 is divided with 5, the residue is 2. When 3 is divided with 5, residue is 3. When 4 is divided with 5, residue is 4. When 5 is divided by 5, residue is 0. When 6 is divided with 5, remainder is 1. Similarly, we can write the remainders. Since we have 5 remainders, each state will represent a remainder so that we require 5 states. Here are the 5 states, and if the machine halt at Q0, the output is 0, that is remainder. When the machine is halt on Q1, output is 1, that means remainder. When machine halt at Q2, the output is 2, that is remainder. When machine halt at Q3, the remainder is 3. When machine halt at Q4, remainder is 4. Now by seeing this information, we can draw the transitions. If the input is 1, the output should be 1. That means when output is 1, it has to reach the state Q1. So that Q0 on 1, it is moving to the state Q1 and output is 1. If the input is 2, it has to get the output 2 so that Q0 on 2, it is reaching the state Q2 and output is 2. If the input is 1, 0, it has to get the output 3, that means it has to reach the state Q3. With 1, it is already reached Q1, so Q1 on 0, it is moving to the state Q3. If the input is 1, 1, output should be 4, that means it has to reach the state Q4. So with 1, it has reached the state Q1 and Q1 on 1, it has to reach the state Q4 to get the output 4. If the input is 1, 2, it has to reach the state Q0 because the output is 0. With 1, it has reached already Q1. Q1 on 2, it has to reach Q2. That means the transition is Q1 on 2, it has to reach Q0. If the input is 2, 0, it has to get the output 1 so that it has to reach the state Q1. That means with 2 it has already reached Q2 and Q2 on 0 it has to move to the state Q1. If the input is 2, 1, it has to reach the state Q2 so the output is 2. That means with 2 already it has reached Q2. That means and finally it has to reach the state Q2 so that we have to write a loop with 1. If the input is 2, 2, it has to reach the state Q3. So with 2 already it has reached Q2. So Q2 on 2, it has to reach the state Q3 with the input alphabet 2. Next string is 100. That means if the input is 100, the output is 4. That means it has to reach the state Q4. With 10, already it has reached the state Q3. So Q3 on 0, it has to reach the state Q4. The next string is 101 and it has to reach the state Q0 because the output is 0. With 10, already it has reached the state Q3. So Q3 on 1, it has to reach the state Q0. The next string is 102 and output is 1 so that with the input 102 it has to reach the state Q1. With 10 already it has reached Q3. So Q3 on 2 it has to reach the state Q1. Next input string is 110 and output is 2, so it has to reach the state Q2. With the input 1 1, it has reached the state Q4, so Q4 on 0, it has to reach the state Q2. So Q4 on 0, it has to reach the state Q2. The next input string is 111 and output is 3, so that it has to reach the state Q3. With 1 1, already it has reached the state Q4, so that Q4 on 1, it has to reach the state Q3. Next string is 112, output is 4, so that it has to reach the state Q4. With 1 1, already it has reached the state Q4, so that Q4 on 2, it has to reach the state Q4. Q4 on 2 means it has to in the self loop with 2 and it is reaching the state Q4. Each and every alphabet is defined on all the states except Q0 on 0. If the input is 0 and when it is divided with 5, the remainder is 0, so that it has to be in the same state Q0. So that Q0 on 0, it is moving to the same state Q0 and Q0 is the starting state. Now each and every alphabet is defined on every state, so Moore machine is constructed and there is no final state in the Moore machine. Please do subscribe and thanks for watching.